Now do it. There you go. See, what ends up happening with the Rubik's Cube is that, by the way, I'm live right now, just so you all know. But what ends up happening with the Rubik's Cube is that people tend to take a solved Rubik's Cube, they turn it a bunch of times, and then they undo what they did. And they're basically like, look, I solved it. Like,
I'm not smart enough to do that.
Like, no, you didn't. Now, the other thing that people try to do, they basically try to say, they're just like, oh, if you just turn it like these two turns over and over again, eventually it'll solve itself. Incorrect.
Yeah, I thought that, not gonna
Yeah,
lie.
incorrect. Here's the thing. The only way that particular method works is if you are somewhere within the cycle of a solved cube, okay? I'm trying to get back to a certain location. It's only if you're within the cycle of a solved cube, because if you do this cycle of just turning two sides, it will cycle through 128 different versions of the cube. Think about that, 128. Watch.
I'm not even that old.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4, 5, 6, 7, 8, 9, 30, 1, 2, 3, 4, 5, 6, 7, 8, 9, 50, 1, 2, 3, 4, 5, 6, 7, 8, 9, 80, no, 60, whatever. I'm just gonna, I lost count, so I'm just gonna keep going.
Oh my god. You're doing that fast.
The general idea is that eventually it will cycle back as long as you don't screw up to a solved cube. But that's only 128 cycles. Tell me, how many different ways can a Rubik's Cube be scrambled? More than a quintillion. 43 quintillion.
Oh, I was going to say 6 trillion. So I was really off.
Yeah. More than a million, more than a billion, more than a trillion, more than a quadrillion. It's 43 quintillion. If you started counting to 43 quintillion, the molecules in the universe would all die before you reach the end.
Even if
Something like that.
This, what do they represent?
Yeah, you still would never get there. You never get there. Nope. Now, my point, I don't know, but my point being, with the assumption that it takes you 1 second to say every number, which it clearly doesn't, because eventually you get to like 1,423,000. It takes you more than a second.
Oh my God, you're right.
Not to mention, you would have to sleep at some point.
Oh my God, you're right. I
Yeah.
didn't even think about that.
You have to think of the,
1, 2, 3,
yeah.
4, 5, 6, 7, 8, 9, 10.
Yep. So anyway.
1,246, 1,247.
My point being, though, that people try to be like, "Oh, I have a cousin who knows something. Oh, I just peel off the stickers." Oh, no, you're all silly to me. Anyway, back to this. Oh, that is for a class that I was doing earlier today, discrete math. We are doing something called graph theory, more specifically something called Hamiltonian circuits, in which there is a mathematical principle behind going through every single vertex exactly once without repetition. Yeah.
Is it okay if I sit in this chair?
Nah, you gotta be back there.
Well, I can sit right there, but with this chair.
Oh, with that chair?
Yeah.
How? Now, if you can figure it out, you can. As for today, first and foremost, y'all know you have Monday off. I won't see you again till Wednesday. I know, right? I am going to be assigning you a homework in regards to practicing some of the concepts that we have been learning and will continue to practice today. I will expect that homework to be done before class on Wednesday. Not that you would do it at the last minute, but that you would submit it before that deadline. And then we'll see what happens from there.
Considering how many people didn't turn in your project, we wait till last minute.
To be fair, a good number of people turned in the project, probably about like 80+%.
Must be nice. Who in here did not turn in their project?
Don't do that to people.
Where's Skylar? Skylar's not here.
Okay, don't do that to people. Don't call people out.
Well, they didn't
Anyway.
raise their hand. It was a choice.
Yeah. So if you're in the chat and you haven't left a comment yet, please make sure that you do so. But what I'm going to do is kind of twofold. Number one, in a moment, I am about to post a PDF of the worksheet that I would like to work on today. Now, what I'm going to suggest to all of you, the PDF that we're going to work on, some of the problems look kind of small. I'm going to suggest for all of you here live today, if you would open up the Chromebooks to access that PDF. I'm going to have it up on the screen, of course, but you're going to see it's going to be much better for you if you can zoom in on the computer screen because it makes it a lot easier. You can open that if you want. I got you. Yeah. So I'm going to post this PDF and I'm going to tell you exactly what we're going to be doing with it. So let's see, add file. Let's see here. PDF for today.
Yeah, I was gonna ask actually.
Here we go. What's up?
Actually, no, that's not. I can actually ask it.
There we go. I just posted it. Make sure you can access it and open up that PDF file. I need you to make sure that you can. Go ahead with your question.
What is it a possibility that for that project? If I get it to you within the next 2 days, I know you can't put it in for grade, but if you put it in for like half credit for like the year as a whole.
For the year as a whole.
Yeah, because like you can like not put it in for a marking period, but you put it in for like so like on my report card, my grade will be whatever it is. But then I think you can put it back there.
Well,
I don't know how it works.
my rule of thumb would come down to this. If you submit the project to me this late, then obviously there would be a proportional penalty that would go into whatever the grade would be. If I am able to go and resubmit a number, that number would obviously improve the marking period grade, but I can't say by how much because it depends on the quality of the project and, of course, how much points I end up deciding to take off. So that's what I'll say about that.
Let me think.
Well, any other questions, email me. But make sure you can open up this PDF file because, like I said, I'm going to be working off of some various problems. Now, this has mid-chapter test. This is not a test. This is a practice. But you can see how small some of those problems appear on the screen. And I would prefer if these problems, when we decide to go over them, are written down in a safe and secure location. So, yes. No, I do not, which is why I asked for the Chromebook. Do you get the Chromebook today? No, I know. We're going to write these into our notes, though. Trust me. This is why I asked for the Chromebooks, because I knew it was very tiny. I know. And with that, if you do not already have them out, I'm going to need those notebooks out and open. Ooh, I think other people in the class are a little bit upset that you say you're the only one that participates.
Yeah, I'm a little upset. Everyone else kind of just sits around. Email.
Yeah, see? I didn't have to say what you said, but like.
Yeah, see, I'm not gonna say what you said.
Yeah.
Doesn't make any sense.
Okay.
Well, it was a.
So my objective is to be able to go back and forth between said notes and this worksheet. I'm going to try and zoom in on certain problems, of course. There we go. I'm going to try and zoom in on certain problems, of course, but I am going to be adding certain things to my notebook. So what I'm going to be calling this today, for the sake of argument, we're going to call this rational practice. I'm going to call this rational practice as a title. So that's what that thing is going to look like right there. Let me zoom in a little bit more. There we go. I'm going to trade out markers because this one is going on me. Here we go. Get rid of that. Get rid of that. Almost made it. And I'm going to copy down a couple of problems. I'm actually going to copy down problem number 2 and problem number 3. And I'm going to copy them down very precisely. But I want to make sure that you copy them down as well, because I'm going to have a lot to say about this. Over the course of the past several class periods, we have been working with simplifying rational functions. Now, with this first couple of problems right here, numbers 2 and 3, these two problems are using multiplication and division to simplify these rational functions. The general rule of thumb that I have given you is that when you are simplifying these rational functions, you have to make sure that, number one, the terms match exactly, but number two, that they're being separated by nothing more than multiplication or division. Now, in this case, I'm going to flip it back real quick. I've written out this problem, and you can see that everything is being separated by multiplication and division. And you can see I've written down everything precisely as it looks on the worksheet. I've written down everything precisely as number 2 looks on the worksheet. Somebody correct me. I've written down everything precisely as it looks on the worksheet. What's wrong? What's wrong with this thing right here? Why am I repeating and emphasizing the fact that I've written down everything precisely as I see it on the worksheet?
The top of the right isn't there.
Do you know why? The top right, I have not written. I am going to write it, but I'm not going to write it exactly as you see it on the worksheet. I'm not going to write it exactly as you see it on the worksheet. Last class, I showed you an example that looked like this. I believe it was x minus 6 and 6 minus x. And I tried to show you that those two terms do not cancel each other out as they stand right now. They don't, because they do not look exactly the same. Instead, I factored out -1, treating it as if it were a greatest common factor. So we took this 6 minus x on the bottom last class. First, I rearranged it to look like this. That was loud. I rearranged it to look like this, and then I factored out a -1, so that what was inside of the parentheses matched exactly what was on the top of the fraction. I did that so that I could simplify this thing, bam, bam, to just become a -1. I'm going to do something similar to this 1 minus 2y. As I'm writing down the problem, I'm going to do something similar where I'm going to flip around the terms to make it -2y plus 1, but then I am going to factor out a -1 to make it look oh so nice. It would end up looking like this. That's the way that I'm going to write down the problem, because I'm just looking ahead, knowing that I would love to cancel out that 2y minus 1, but the only way that I'm going to be able to do it is if I have matching terms on the top and the bottom of the fraction. Now, in a few minutes, I am going to let you actually finish this problem and another problem on your own. I just did a little setup right here, and now I want to write down the next problem for the next piece of setup. So we're going to come back to this. Leave yourself some space so that you have room to do this problem. And now I want to write down number 3. What is so weird about number 3 as you see it on that PDF? What's so different about number 3 comparatively to the most of the problems that we've done so far? I'm going to try and write down number 3. But I'm not going to write it down exactly. This one that I wrote down?
Yeah.
Cool. Which portion?
I think.
Gotcha. Like I said, the only thing that I changed, the absolute only thing that I changed was this top right portion, because I needed it to look slightly different.
Okay. Thank you.
Now I'm going to write down number 3. But I'm not going to write it down precisely as they have it on the PDF. Now on the PDF, they have something there in the middle that is going to have to be changed. Which one? This one? This was the other one. Are you talking about the PDF? Well, no, this is the first page. This is all I've done on the first page so far. This is all I've done on the first page so far. And I said, I'm going to come back to this. Leave yourself some room because you guys are going to work on this in a little bit. But now I began working on number 3. Now, number 3 is not precisely the same. On number 3, on this worksheet right here, on this PDF, on number 3, you have a division symbol. I don't like that division symbol, and I would like to change that division symbol. There was like a 3-letter thing, not GCF, but there was a 3-letter thing that you guys learned like back, or 3-word phrase, I should say, that you learned back in the day for dividing fractions. Flip, change, switch. Keep, change, flip.
Is that it?
Yes.
Oh, okay.
People will refer to it as like KFC or KCF or some junk like that. Keep, change, flip. You know, I don't know. But the fact of the matter is, when I look at this problem, I am going to keep the first fraction. Definitely keep the first fraction. Then you change that division to multiplication. You change that division to multiplication. Absolutely, yes. Then you flip that last piece of the problem. You flip that fraction. And that fraction will now look like this. That's what it would now look like. It is vitally important that you do something like that in order to get the problem started correctly. I would rather it be multiplication, because if I'm dealing with division, it's really going to mess me up in the long run. Let's just change it to multiplication, flip the fraction, and we'll be good moving forward. Then I can begin all of these factoring techniques that I would like to do. Now, in a few minutes, as I said, you guys are going to be working on these 2 problems, numbers 2 and 3 from the worksheet. But I wanted to do a few bits of setup. Setup number 1, I changed the top right of that first problem. Setup number 2, I changed the division to multiplication and flipped this fraction in the other problem. Setup number 3, I need to remind you of the Tucker method of factoring. Now, I reintroduced factoring to you before break. We talked about it a bit more on Monday. We got more practice with it on Wednesday. So now this is the 4th straight class period where we had to go back to some level of factoring. I had an interesting conversation with a class yesterday, my Algebra 2 class, which, by the way, you're actually, well, you're not ahead of them. They're ahead of you by 1 day. But the interesting conversation that I had with them, a few of them, was them saying, like, you know, I get the Tucker method when you talk about it in class, but when I try it on my own, right? That's what they're trying to say. Would you agree with that sentiment, though?
I don't know how to do anything. I don't know how to find anything. I just feel whenever I go to do it at home, I just feel stupid because you're not there.
I'm sorry.
It's okay. But I don't want you in my house.
Oh, that'd be weird. That'd be weird.
Yeah, that would be weird.
Well, let me ask you the following question then. Take the number 15 and break it apart.
14 and 1.
By multiplication.
3 and 5.
You factored it.
Okay, yeah.
Now, hold on. I'm building an argument here. I'm building an argument. You can take a number and just factor it by breaking it apart like that, correct?
Yeah.
The general idea of factoring quadratics is very, very, very similar. except you're taking this weird form of a quadratic in the form of a, ax squared plus bx plus c, and you were trying to figure out, okay, what two things could I break it into in order to factor it correctly? What two things can I break it into to get its individual components, its DNA per se, of the problem? It's an interesting ideal. You could take any number, number whatsoever, and you can actually determine whether or not it has its own unique DNA or if it's a prime number. Give me a number that's not 15. 59. 59, I can tell you right off, is a prime number. You can't factor it. 59 is unique unto itself. It cannot be divided by any number other than one and itself. Give me another one.
That's everything I do is bad.
No, that was a good number.
Let's do.
Did she say everything I do is bad? I said it was a good example.
Let's do 38.
38. Now, 38 can be divided clearly because it's an even number, correct? If you take 38 and you break that thing up, it has the unique DNA. What is that? 19? Yeah. Now, think about this. No other number in existence has the unique DNA of being a single 2 and a single 19. No other number in the history of the universe has the unique DNA of 2 times 19 as its prime factorization. It's insane to think about that. But the idea of taking this number and being able to break it apart, that's what this process does. Now, this is the process that I've walked you through, and you guys are going to have practice with it in a few minutes. Number one, take out that GCF. Let me move the camera over so those people at home can also see. There it is. So they can also see. I moved it over so they could see that. I left it over from yesterday. Number one, you take out a greatest common factor if you can. Now, I'm going to tell you, throughout these two problems, there's only one location you can take out a GCF. Only one. Where is it? In these two problems, there are 8 locations where you have the possibility of GCFing the problem, but only one of them will work. Where is it? Most of them you can only take out a 1. In fact, well, except with, not counting the top right. Most of them you can only take out a 1 as a GCF. Where can you take out something other than a 1? Look right here. You can take a 3 out of both of those terms. That's the only portion of these two problems where you can take out a GCF. Now, keep in mind, the Tucker method of factoring is specifically for factoring quadratics. It's for factoring quadratics. Now, let me get rid of that. That are in the form ax squared plus bx plus c. The Tucker method of factoring is mainly for quadratics. Meaning, you are going to be able to factor this problem up here, this portion here, this portion here, and this portion here. Those are the quadratics that you would be able to factor. This is the shorthand for the Tucker method. Take out a GCF if you can. Multiply A times C. Find me those magic numbers. The magic numbers that have to multiply to A times C and have to add up to B. Perhaps I'll do this first portion with you. We'll see what happens. Throw things into a T-chart and simplify if you can. And ultimately write out your factors. I'm going to do this first one with you. And then I'm going to set you off to complete these two problems. I'm going to do a little side note right here. I'm not actually going to call it a side note. Write down 9y squared minus 1. You cannot take out a GCF. You cannot. But I would continue with the rest of the Tucker method with multiplying A times C. What do I get when I multiply A times C here? Keeping in mind that the B value in the middle is 0. The B value in the middle is 0. What do I get? Second? Almost. You got to treat that,
-9.
Oh, no,
yeah,
no.
as a negative.
Oh,
Now that's important though, because if you left it as positive, everything would fall apart. It's got to be a -9 for this particular problem. Can you give me two magic numbers that multiply to -9 and add up to the B value of 0? Now this is the key. If you told me it was 9, then I couldn't get, would not be able to get that B value at all. But what two magic numbers multiply to give you -9 and add up to 0? Oh, she said it in the chat. You guys can't see the chat right now, but she said 3 and -3. Actually, probably some of you can see the chat, but whatever. Said 3 and -3. I would throw those values into a T-chart. In the top of the T-chart, well, how do I break up the 9y squared? Do I break it up as 9y and y, 3y and 3y? How do I break up that 9y squared? You don't have to make the decision. If it's 9y squared, make it a 9y and a 9y. Because that T-chart will eventually simplify. Let me zoom in right there. That T-chart will eventually simplify. And it will simplify, well, 9/3 reduces to a 3/1. You have to have that 1 down there. And that 9/-3 will reduce to a 3/-1. Ultimately, once I have simplified that T-chart, I can then finally write my factors as 3y plus 1 and 3y minus 1. Those are my factors. This process, although complicated at first, once you get used to it, becomes one of the easier things. We've been doing this method, this process, this journey in this Tucker method since September. Now, some people back in September are like, well, I'm just not going to learn the Tucker method. Okay, that's fine. If you have an alternate way of doing these problems and it works and you can show me the work, then do it. Absolutely. If you have an alternate way of doing this and you can show me the work and back it up, awesome, fantastic. But this is a method right here. Was it this class? I can't remember if it was this class or yesterday's class. I had a conversation about factoring, and someone was talking about one year a teacher taught them like 2 or 3 different methods. Was that was this class? Okay. If you're taught multiple methods, those steps tend to overlap each other, right? And it's just like you might accidentally do a little bit from the first method and a little bit from the third method, and you're like everything's getting all confused. Officially, I'm teaching this as the one method that I'm teaching, but I'm saying that there are alternate ways of doing things, and if you prefer those ways, go for it.
See, the reason I get messed up is because if I look at it straight, it's a cross. If I look at it diagonally, it's an X. I learned.
I see what you're okay. I see what you're saying. But that's why in like my directions I usually say T-chart. I know what you're saying. Who taught you the X, by the way? Who? Okay. See, I was never taught the X. In fact, I was never actually even taught the Tucker method. I was taught how to do this stuff intuitively. It's very weird.
No, but you're smart. So you're able to do it.
I just have a question about the x, though. How would I do that for this problem?
You would-
Because now keep in mind, I don't know how to do the x method.
So, literally, when you look at this is already the bottom of the x.
-9? Like right here?
No.
Oh, I'm sorry.
Look, if you 0 and then 3, -3. That's how you do the x. But from there, like, cool, we still have whatever we have. I just don't know how to get from here to there.
Okay.
And then,
And that's the thing. Because I'm not familiar with this method, I don't know how either. Because I've never been taught this method. I understand what you're saying. I do understand what you're saying, though.
I don't know. So I'm trying to learn your way.
Mhm.
But with that thought in the back of my mind, it's difficult because I remember like pieces.
I understand. Okay.
And I did really good with it. I think that's why it's really frustrating because I did so good with the X method. Remember my little book I pulled out?
Mhm.
I had pages upon pages of me doing it flawlessly.
Can I tell you a secret, though, in regards to the Tucker method?
Sure.
If this number, and you're going to see this on the next example, because I'm just going to go ahead and do the next couple examples with you guys, the two that I've been hyping for a while. If this number were not a 9, if this number were a 1, if it were a 1, you don't need the t-chart. And you actually don't need to do this step either. You pretty much just focus on what's in the equation. You'll see what I mean in a moment. But when I say, if this number were a 1, then you can technically bypass all of this if that first number were a 1. If it's not a 1, then it's going to get a little icky. Here's what I've learned about the X method that you're referring to. What I've learned about it is that if this first number were a 1, it works every single time perfectly, perfect. But if this number's not a 1, then that X method falls apart. That's what I've kind of learned from it. Do you know what I'm saying? I'm sorry. Here, let me show you where we're going to go with this problem now. Where we're going to go with this problem, with this particular problem, is the fractions will look like this. 3y plus 1, 3y minus 1 in the top left portion of this problem. Let me zoom out. There it is. The problem will turn into this because it would have been the factored form of the top left side of the problem. Everything else will remain the same. Everything else will absolutely remain the same until we start canceling some junk out. But the objective and goal is to be able to factor first. Factor first, factor first. Then, once everything is factored, then we can begin canceling junk out like no tomorrow. For example, can you tell me specifically what cancels right now? The 3y minus 1s. What else? The 2y minus 1s. Anything else?
I was going to say the positive one and negative one, but I don't know.
Where's the positive one?
The plus one. Oh, just kidding. That's in the parentheses, meaning you can't take from it.
Yep. And that's the rule that I've been hyping for several class periods, right? So, final answer, you could either write it down like this, which is acceptable, or you can distribute. You can distribute that -1 to make it look like that. Either one is an acceptable answer. Either one of those is an acceptable answer. And you'll see on that PDF that you guys have open up on your screens, you would be able to see on that PDF that is one of the choices. I can't remember which one it is. Let me see. Oh, it's the first one. It's F. Now you can see the choices that they give you on this thing. The choices that they give you are specifically designed to mess you up, but it is most definitely the first one that you need. Oh, absolutely. Absolutely. Let me separate this. This part was the Tucker method that I needed. Just going to label that right there. It's interesting, though, because I know you mentioned the X method. There seems to be a disagreement between. Now, you had Miss Out for Algebra 1. Okay. There seems to be a disagreement between a lot of the Algebra 1 and Algebra 2 teachers in regards to what's the best method of factoring. And my opinion is there is no best method of factoring. There is absolutely no best method of factoring. It's just that some are preferable over others.
That's so funny. I'm just imagining teachers sitting in the like teacher room eating like their lunch or something.
Yeah, do teachers talk about teacher stuff or just other people's stuff?
It depends. A lot, depending on what we're, obligated to do at the moment. But teaching stuff, quote unquote, talking about the best methods of teaching.
I can just imagine you in Mr. Liston's room. Like, gross.
Have you ever gone into like a genuine argument over math?
Oh, yeah, Liston and I do that all the time.
Really, over math?
Yeah.
That's hilarious.
They're friends. Don't you guys eat wings together?
I'm not in that crew.
Oh, I'm sorry.
I didn't want to be in that crew.
Oh, sorry. Did I just hit like a sour spot? Oh, God.
No, I have their stuff up there. They give me stuff all the time. I got the magnet up there. I got the glasses. When they went to Buffalo, they came back with a buffalo wing bow tie for me.
Aw.
Yeah.
So you guys are like chill. You just don't want to.
I just don't want to eat wings.
Stop with them.
Anyway, back to this. So now, look at this problem right here. Look at the top left side of the next problem. Remember what I told you about the leading coefficient. What is the leading coefficient on this equation? Well, that's the variable. What's the coefficient?
Oh, one.
Yes, it's a leading coefficient of 1. And when you have that leading coefficient of 1, you are able to take major shortcuts. Major shortcuts.
Can we just appreciate the fact that I said I wasn't going to participate because I was mad, and now I'm participating anyway, but none of you will.
They've been.
This is outrageous.
I think doing my work this market is very good, so
You're not, or you are?
no, I am.
Oh, I also think you have a misconception as to what participation is.
Okay, not
Participating doesn't mean talking every concept.
Okay, go.
Whoa.
Literally, go at yourself. Okay, fine. You want me to not talk for 10 seconds? We'll do that.
You got to take her place.
No, I don't want to. I'm just doing my work like a good person.
Good person. Goodness gracious. Now I know we were talking about the X method before, but like I said, if the leading coefficient is 1, literally, you can just ask yourself the following questions. What two numbers multiplied to negative 20? Look where I'm pointing. What two numbers multiplied to negative 20 and add up to negative 1? Look where I'm pointing. I'm going to do it again. If the leading coefficient is 1, then you can just ask yourself the following questions. What two numbers multiply to negative 20? Look where I'm pointing. And the same two numbers have to add up to negative 1. If you can determine those two magic numbers, then you can bypass most of the Tucker method and jump straight to the factors. What two numbers? Oh, she already said it. Sorry. In the chat, she already said it. I didn't even ask for it. But yeah, 4 and negative 5. Watch this. C plus 4, C minus 5. This only works if the leading coefficient is a 1. If the leading coefficient is not a 1, then you're going to have to go through the rest of the factoring method. You could do the same thing with this portion of the problem, the bottom left portion. It's a leading coefficient of 1. So I need two numbers that multiply to positive 5, and add up to negative 6. Ooh, people hit a brick wall yesterday too. I need two numbers that multiply to a positive and add up to a negative. That'll work. Yeah, because they have to negative 6. C minus 5, C minus 1. You are only able to jump to that and skip the rest of the Tucker method if the leading term is a 1. This bottom right portion right here, the C squared minus 16, we've done problems like this over and over again. In fact, it's very similar to the side note that I gave you. I gave you a side note in your notes either Wednesday or Monday. I can't remember which one it was. Say it again? So that was Monday. Yeah, I gave you a side note, but I think in the side note it was like minus 4, right? Yeah, but this is minus 16, but it's the same concept. Two numbers that multiply to negative 16 and add up to 0. And you're only allowed to do this if the leading coefficient is a 1. You're only allowed to do it if the leading coefficient is a 1. Notice I didn't do anything to the top right. The top right, I just have to take out a greatest common factor. That's all that I have to do is take out a greatest common factor. Remind me, what the heck is it in this one? The top right portion?
Yeah, tell
I learned this doing the algebra 1 here.
But keep in mind the top right portion of this, fraction is not going to be factored like the Tucker method. It's not going to be factored like that X method. It's not going to be factored like any of that stuff. It's not going to be factored using grouping. It's not going to be factored using any type of quadratic factoring because it's not a quadratic. As we stated in this problem, you only have to take out a greatest common factor. In this case, the greatest common factor is 3. That's all that you have to worry about. This is the process that you would have to go through. Factor as much as you possibly can. Factor, 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 factor. Then, after everything has been factored, we can begin canceling stuff out. 1 for 1, canceling stuff out. Top and bottom. 1 cancels for 1. And you are left with nothing more than the leftovers. That's all that the problem entails. That is all that the problem demands of you. Now, I have a big problem that I want to focus a lot of energy on. That's on this worksheet. Do you know which one it is on the PDF? You can probably guess by looking at the PDF. Yes, I am. I'm talking about number 4. Now, I'm not going to write it down just yet. I want you to look at number 4 on the PDF. Look at number 4 on the... Yes. No, go ahead. You had your hand up for a question. Okay. Looking at number 4. Would you agree that it looks like a hot pile of garbage? Yeah, right? There's like 3 division symbols up there. What the heck is even going on? But what do you notice about one of those division symbols? What do you notice about one of those division symbols? It's what? Don't worry about the squaring. I'm talking about the division. Say again? It's bolder than the others. I'm talking about the division bars.
That whole problem up there is divided. It's the same exact thing as what is it? The one that you didn't like with the division one. Number 3 is the same exact thing as number 2, except it's just formatted.
Yes. Everything. I'm going to repeat that for those in the chat, just so you know. But she said that number 4 is almost exactly the same as number 3, except it's formatted differently. I agree wholeheartedly. It's only just formatted differently. It's designed to make you intimidated of it. If you've ever seen problems like that, a lot of people just immediately shy away from them. Now, what I'm about to do is I am writing down I am writing down exactly what number 4 is actually asking. And I would ask that you do the same thing in your notes. Once I have this written down completely, I'm going to switch the camera back, and I want you to compare what number 4 looks like compared to what I have written down. So let me zoom in a little bit on number 4, a little bit more, I should say. I think that's all that'll let me. Yeah, that's all that'll let me do. There's number 4 right there. Now I'm going to flip to my camera. That's what it really should look like. That is what it really should look like. You need to look for the thicker division bar. You need to look for the thicker division bar. And that is where the middle of the problem will actually take place. They're asking for you to take that fraction and divide it by this bottom fraction. Now, yes, we're going to have to do some maneuvering in a moment on paper, but that, what I have written down, is actually what they're asking you to do. I'm just going to flip back one more time and then erase those things on the board. Look for the thicker division bar, and you can see that top fraction divided by that bottom fraction. The formatting is weird, but that's what they like to do. They may throw problems like that at you just to mess you up. I know. It is. A lot of the time when it comes to state testing and whatnot, they're basically designing problems to make you mess up. That's all that they really care about. Hey, let's put a problem in here that's really just going to screw them up.
Their problems are purposely designed to mess you up, and it's not.
It's to show your critical thinking skills.
To an extent, you know, it's like if you're somebody who runs, track or cross country or something, it's, when you go to the actual competition, sometimes you'll go to some of the higher level competitions and they'll have like not for track, I should say, but for cross country, they'll have like courses that are a bit more difficult because of the hills. Oh, why can't they just give us like a straight path? Because that would be a challenge. And they're really going to divide the winners from the losers, Well, that's in cross country, I should say.
Well, that's physical training. This is mental stuff. Like you just don't know how to do something.
Well, physical training and mental training, some might say, are not one and the same, but have a lot of overlap. So, first, I'm going to do this. And I want you to figure out what the heck I just did. I want you to write this down exactly as I have it, and I want to point out what I've done and what I've not done. I want to point out what I've done and what I've not done. I've only done one specific thing to all 4 parts of this problem. I want you to notice I have not changed the division sign yet. I will eventually, but I have not changed the division sign yet. Everything is exactly where it's supposed to be. But I have done one magical thing to all 4 parts of this problem, and it's 3 magical letters. What is it? That's one magical letter.
C.
Yay, we did it. I can feel your frustration with everyone else. You okay?
No. Obviously, if you want to know the truth, I'm not okay.
I'm sorry.
Because it pisses me off. And then Gio made it clear that he doesn't have to talk every 5 seconds. But sorry that I actually care about my education. I'm going to ask questions to develop understanding. And those hard problems that you don't know how to do, the reason I'm asking questions is because I have critical thinking skills, so I can figure out how to do those problems.
To be honest, she and I had a conversation on Wednesday. I like the questions because they do develop the understanding of the problem. Absolutely, they do. And her asking questions is incredibly beneficial to the rest of you. Is that, it kind of sums up what we talked about? Yeah. you got to take out a greatest common factor. But in some of these problems, the greatest common factor is only a number. In this case, in the top left, it was only a 3. Same thing with the top right, you can only take out a 6. But in the bottom portions of this problem, both terms had a variable in common, in this case an m, and you can take out that m out of both portions. Now, I'm going to have to take care of that division symbol. I'm going to have to take care of that division symbol by doing that keep, change, flip portion that we talked about. Here is the change flip. Here is the change flip. I didn't do the keep just yet because I got to do one more thing to that first fraction. I didn't do the keep yet. In fact, I'll just write this portion down first. But I definitely did the change, and I definitely did the flip. The reason why I didn't write the top left portion of this problem is because it can still be factored. It can still be factored. And this, again, once again, goes back to that side note that we did on Monday. It can be factored into m minus 2, m plus 2. This is what you're going to have to focus on. You're going to have to focus on making sure everything is multiplication. You're going to have to focus on everything being factored. Sometimes taking out the GCF will take care of those quadratics. And then once you get it down to this portion where everything is completely factored, you can begin canceling junk out. Question. You can cancel out this m plus 2 with this m plus 2. But what about this other m plus 2? Some people have told me in the past to cancel out this other m plus 2 as well. Yeah, you can't. There has to be a matching m plus 2 on the bottom that's still there. It has to be still there. So that m plus 2, this extra one on top, is going to stay there. This m minus 2 and this m minus 2 will also cancel each other out. Wonderful. Oh, look at this. This m with this m. Yeah, they're only being separated by multiplication division. This m and this m will cancel each other out. Those numbers can simplify, but I'm going to make it a lot easier for you. Those numbers can simplify. But watch this. What's 8 times 3? What's 4 times 6? Oh, you got a 24 on top and 24 on bottom. Oh, okay. That's cool. If you look at the PDF, that you guys have on the computers, look at all 4 choices. Clearly, hopefully, at this point, you know which one is the correct answer. But what do you notice about the other answers that they gave you? Yeah. Here, I'll flip it over. Boop. There's the first one, F. There's the second one, G. There's the third one, which is the correct answer, M plus 2. And then there's the fourth one, J. Oh, man. It's all messed up. Oh, this problem. Okay. I want to do one last thing to wrap up today. One last thing. I want to do an addition problem. It actually is the very next problem on that PDF. I want to do number 5.
Numbers 2 through 5, we have the answers for.
Say again?
So numbers 2 through 5, we're going to have the answers for.
Well, you don't have the letter, but yes, you will have the final expression answer, yes. Now, something for like numbers 7, 8, 9, 10, like stuff that has graphing, we have not touched graphing yet. So don't worry about that right now. And then something like number 1, that actually has more to do with graphing, which is why I skipped it for the time being. The one that I kind of hoped we would get to was number 6, but that one's going to take a lot more time. So for now, I want to focus on number 5. Number 5 is different. Number 5, they're asking you to add and subtract these terms together. I had a very interesting conversation with someone yesterday just asking about the merits of being able to multiply by variables and introduce variables where they were never in the problem to begin with. I thought it was a very interesting conversation. I could have kept it going for a long time, but we ran out of time. But it comes down to this. 5, 4, and 10. I'll deal with the W in a moment. 5, 4, and 10 are parts of my denominator. What is the least common multiple of those 3 numbers? Not the greatest common factor, but the least common multiple. Something's really loud right now. You hear it? It's like music playing. Oh, sorry. Yes. I literally just looked at the chat and she said 20 as well. But it's 20. Now we have to deal with the W as well. Because there's a W in 2 of those fractions, there needs to be a W in that first fraction as well. Because if you are adding and subtracting fractions, you need common denominators. Watch what I'm about to do. I'm going to put this multiplication into each fraction. But what I'm multiplying by is slightly different in each term. Technically, what I'm multiplying by in each fraction is a 1. I'm multiplying by 1. But by multiplying by 1, I'm not changing the value of the fraction. I'm just simply changing the way it looks. And that is acceptable. This first fraction will turn into a 4w over 20w. This second fraction will turn into a 15 over 20w. And this third fraction will turn into a 6 over 20w. Once you have all common denominators, you can bring stuff together into a single fraction with the same denominator. Keep in mind that that 15 is indeed negative. Somebody asked me again, Mr. Markey, can you now cancel out the W's? And I said, no, you can't, because that 4W is being separated by a subtraction sign. That's all you can do. I am going to be assigning you a homework, so please pay attention to Google Classroom. We'll see you next time. If you haven't left a comment in the chat, please make sure that you do so. I'm going to leave it open for a few extra moments before I got to go, because I got to go get down to study hall. I have extras of this if you guys are interested. It's a challenge where you have to start on one of the vertices, and then you have to go through every vertex exactly once without repeating anything. Sure, you sure? All right. It's not as easy as you think.
I don't think it'd be easy. Is it on the computer?
No, they got a printout. That's right there. Oh. I'm sorry, paperclip? Yes.